Electrons. Electrons are the smallest whole particle of an atom that we'll be talking about. There are smaller subparticles that make up protons and neutrons, but we won't be worrying about them. We will just be worrying about the electron as the smallest particle. These electrons are located in an area outside the nucleus called the electron cloud. And as you remember from the atom video, they have a negative charge that counterbalances the positive charge of a proton. The number of electrons in a neutral atom are equal to the number of protons. Electrons are arranged in something called shells. These shells hold different amounts of electrons, and they do this as follows. An s orbital, or shell, has 2 electrons. A p can hold 6, d 10, and f 14. Electrons have a configuration, which is how they are arranged and filled inside the orbitals. As you can see in this diagram, this is how we fill them. If you compare this to how the periodic table is arranged, it's quite evident how this works. Each number corresponds to a row in the periodic table. Each section or block corresponds to which orbital is being filled. The first 2 columns are called the S block. This block has lithium and beryllium in it. The P block is the block where boron through neon reside. The D block is where strontium through zinc reside. And the F block is underneath, where cerium through lutetium reside. In order to fill the electrons, you follow the arrows on the diagram on the left. So the first one filled is 1s. The last filled is 7f. Now, if you are not sure how many electrons are supposed to be in that particular orbital, simply count across the number of elements that are listed in that block, and that will tell you how many electrons you can fill into that orbital. For instance, magnesium is in the 3rd row in the S block, and it's the 2nd element in the block. So that means you should be filling up to the 3s orbital. A lot of places do not use orbitals as a way of showing how this is a way of knowing how many electrons there are. But it's good to know and understand this diagram and the concept so that you can more easily understand what's going on inside of an atom. The valence electrons are the last ones in this list that are filled. They're the ones that take place and take part in the chemical reaction. So if we go back for a moment, and using the example of magnesium, magnesium uses 2 valence electrons. These 2 valence electrons are the ones that are in the 3s orbital. Those are referred to as the valence electrons. Everything else is sometimes referred to as the kernel. What that means is that it's just the ones on the inside that don't take place or take part in the chemical reactions. So what have you learned? We've learned that electrons are the smallest particle. Electrons also have a negative charge. We've also learned which ones take part in chemical reactions and how exactly the electrons are organized in the atom.